In it, we divides our spatial plane into uniform grids uniform grids, and besides this we create the hierarchy of a between different layers which are divided into grids. This is using the hierarchical approach, but this is very different from the hierarchical clustering. In it, in this technique, we use density as the main criteria. It is different from the hierarchical clustering in the way that I'm going to show you in this diagram. In this diagram, I'm showing you the same spatial plane is divided into different number of grids. As the root level, there is a single plane, and at the bottom level there are grids, but the size of the grids is smaller than the smaller, very small. And the layer in between the root layer and the bottom layer, the size of the grid is larger in comparison to the layer lying at the bottom level. If we assign a particular number as a 1 to the root layer and the ith layer as the bottom layer, then if we can see that the numbering of the layer is done in I minus 1, I minus 2 up to 1. Here, the advantage of the string algorithm is that it can process multiple query at a time. For example, in other clustering algorithms, the clustering algorithm in a single scan we can perform a single query, but in it multiple queries can run all together in a single scan. In this way, it is very much more efficient than the rest of the clustering techniques. In how it is able to perform multiple queries in a single scan, because it divides the spatial plane into the grids, and if we are processing some queries related to different grids, then they can run without interfering with each other. In this way, it is much more efficient than the other techniques. So here I am showing that key, it is not dependent on the ON, where N is the number of the element in the database. Okay. So it is more efficient, and it is using density. And there is a relation between the number of grids between in the layer at the bottom layer and the layer above it. And in the extension of the string algorithm, that is the statistical information grid, I have told you that it is statistical. The statistical stand for that every grid that was created here holds 5 variables. Those 5 variables are these 5. They are called the cell parameters. The first one is the n, the number of object in the cell or the number of data element in the set. M, small m. The second one is the mean of the all values in the cell. And the third one is the S. It means the standard deviation of all the values of the attribute in the cell. The next one is the minimum. It's the minimum data value, and max is the maximum data value in the cell. So it means that each cell holds 5 variables: n, the number of data elements; m, the mean of that data elements; s, the standard deviation of the all the values in the sets; m is the minimum value of the cell; and max is the maximum data value in the cell. For example, a cell is having 5 elements, 1, 2, 3, 4, 5. Then the number of element n would be 5, as there are 5 data elements, 1, 2, 3, 4, 5, and m is equal to mean, matlab 1 plus 2 plus 3 plus 4 plus 5 divided by 5. It means 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15 divided by 5. So mean would be 3. And standard deviation, for standard deviation, we have a formula that is equals to for every value x minus mean, that whole square upon the number of data elements under root. I shall show you the formula in the next slide. And min is the minimum value. So among 1, 2, 3, 4, 5, 1 is the minimum. So min is equals to 1, and max 1, 2. Our data element set is 1, 2, 3, 4, 5. So max would be 5. And I'm showing you that these statistical parameters are related to each other, as the as we know that in the as have shown you in the diagram, that in the bottom layer there are 4 grid corresponding to a 1 grid at I minus 1th layer. So the if we want to calculate the parameters for the I minus 1th layer grid, then we can simply derive these values from the 4 grid lying parallel to this in the ith layer. This can be said that we can calculate the value of the I minus 1th level grid with help of I plus ith level grids which lies parallel to it. In simple words, cell in the level I correspond to the union of the area of its children at level I plus 1. So for example, um, I can show you the formula. The formula that we can use will be like this. N would be equals to sigma of Ni. It can simply explained as the number of data element lying in these 4 grid create the grid at the I minus 1th layer. So number of all the grids element would be equals to the N of the I minus 1th layer. Similarly, small m is equal to sigma mi into Ni and upon N, means mean into number of element for each cell up and divided by the total number of elements in the 4 cells. And for min, the minimum among the 4 will be the minimum, and the maximum among the 4 cell would be the max for that cell. For S, the formula would be slightly different from the normal standard deviation formula, is equals to under root Si square plus Mi square into N upon N minus M square. So in this way, we just need to calculate the 5 parameter for the bottom layer, and we can calculate with the help of the parameter lying at the bottom layer the 5 parameter for the upper layers, and by doing iteratively we can finally calculate the 5 parameter for the grid at single grid lying at the root level.